All right, these are your notes, students, on subatomic particles. First of all, an atom is the smallest unit of any kind of matter. All matter is made of atoms. Atoms are the smallest unit of any element, and the elements are found on the periodic table. There are 92 naturally occurring atoms, and all atoms are going to consist of three main parts. You're going to have your protons, which have a positive charge. They're located in the center of the atom in the nucleus. One way to remember the charge on that is that the word proton and positive both begin with the letter P. Number two, you have neutrons. They are neutral. Underline the N-E-U-T-R. Neutral means they have no charge. They are also located in the nucleus of the atom. And then the third subatomic particle is an electron, which has a negative charge. It is located, this is wrong, outside the nucleus in what is called the electron cloud. Now, when you look at the periodic table that we pasted into your sign bee or the one in your book, you'll see that there are many different elements, and each element is in a little square, and there's a lot of information inside that square. The following is just an example of how to read this information in each element square. First of all, you're going to have the symbol for oxygen is O. Told you the name of the element. The whole number, the one that looks like it's numbering the elements, is called the atomic number, and it tells you how many protons are in the nucleus. This other number, which when we get ready to use it, we're going to round it, is the mass number. We're going to round it to get the sum of both the protons and the neutrons that are in the nucleus. You can see that an atom of oxygen has 8 positive protons in the nucleus. By the way, that is the only thing that makes an atom with 8 protons oxygen. We'll learn more about how to deal with this later. The atomic number at the top of each square is the same as the number of protons and electrons in the atoms. The mass number is the sum of the protons and neutrons in the nucleus, and you can decode this information even more when you learn about a little mnemonic device called Ape-Man. Ape-Man. Atomic number. What does the atomic number tell you? The protons and the electron number. Mass number. That's this rounded, this number we're going to round up here. It tells you how many protons plus neutrons we have in the nucleus. You're going to need to practice on the next part, okay? All right, so you're going to cover the answers with your hands. Never mind, this is a note to myself. Let's go ahead and practice Ape-Man. And what I would like for you to do is to find the element sodium. Okay, it's a symbol Na. Identify the following information. What's the atomic number for it? It's 11. Mass number is 23. So it has 11 protons, 11 electrons, because these three will be the same atomic number. Protons and electrons will always be the same. And the number of neutrons is 12. Well, how did we get that? Remember the man part of Ape-Man. The mass number is it's telling you the number of the atomic number plus the neutrons. So your atomic mass number is your atomic number plus your neutrons. I am so sorry. I don't use this mnemonic device a whole lot. The mass number is equal to your atomic number plus the neutrons. So I am so sorry. If you're wanting to find out the number of neutrons, you're going to do mass minus atomic number. 23 minus 11 gives us 12. Okay, now there's some elements at the bottom. I would like for you to try to do the element calcium. Do the element calcium. For each of these elements here, you're going to figure out the atomic number, mass number, protons, neutrons, and electrons. Do calcium, please. Pause this. Come back when you're done. All right, calcium has an atomic number of 20, a mass of 40. Because you have an atomic number of 20, your protons and electrons are 20. We're going to star those again. Atomic number gives you the protons and electrons. Your neutron number will be mass minus atomic number. Now do boron and pause. Boron has an atomic number of 5, mass number 11, protons are 5, neutrons 6, electrons 5. Now do phosphorus. Pause. Phosphorus has an atomic number of 15, a mass of 31, protons 15, neutrons 16, electrons 15. Notice these three are the same. Remember, your atomic number tells you your protons and electrons. Remember, to get your neutrons, you're going to do mass number minus atomic number. Finally, do potassium and pause. Potassium, atomic number 19, mass 39. Because the atomic number is 19, your protons and electrons are 19. In order to get your neutrons, mass number minus atomic number, 39 minus 19 is 20. So now we know that protons and neutrons are in the nucleus. The nucleus is in the center of any atom and is kind of considered like the brain. It's also where the mass is contained. But what about the electrons? Where are these located? They are located in an undefined space that surrounds the nucleus called the electron cloud. It is impossible to determine the exact location of electrons within the cloud at any particular moment. So I want to go back and talk about protons and neutrons. Each proton and neutron is so tiny, there's no way any kind of electronic balance to measure mass could work. Well, it can, but the problem is it comes up with such a small amount, like 0.0000000 something grams, that it just really is an unmanageable number. So scientists decided that it would make sense to create a unit that was the exact mass of one proton. So they weighed the mass of a proton, figured out what that was, and said, okay, anything that has this mass, we're going to say it is one atomic mass unit. And the abbreviation for that is AMU. Interestingly, when they measured the mass of a neutron, they found out it also was 1 AMU. If you remember back to the Bill Nye video we watched in class today, an electron is only a very small fraction, like 1/10,000th the mass of a proton or neutron. So that little particle that's zipping around the nucleus has such little mass that we say that its mass is negligible. So protons and neutrons weigh 1 AMU. Electrons, their mass is negligible, which means it's so little we don't even count it. So when we get to talking about the mass of atoms, we're talking about how many protons and neutrons they have. So keep that in mind for the future assignment. Go ahead and do the homework of atomic basics. It's due next class. Remember to only do parts A and B, and we'll check it when you get back in class. Thanks.